Alrighty, let's go ahead and use this video to do some examples. These are your rules of exponents, or laws of exponents, or properties of exponents, or whatever the heck you want to call them. Like I said, the name really doesn't matter, the principle behind them does. And remember also that I'll be using some of the problems off of the worksheet that I made for you, where I basically use some scans from textbooks and stuff like that. Let's do a couple of numerical ones first. Now remember, anytime that I'm given something that has an exponent, that exponent can tell me up to three things. So for example, if I have 16 to the negative 5 halves, 16 to the negative 5 halves, that exponent is actually telling me to do three separate things. The negativeness of it is saying flip me over, reciprocalize me, or however you want to talk, or however you want to describe that, okay? The 5 is saying raise me to the 5th power, and the 1/2, the 2 in the denominator, is basically saying square root me. Now, the great thing about all of this is that you don't have to do it in any particular order. Because really what you're doing is, if you're doing three distinct things, right, you basically are splitting it up into its product of 1/2 times 5 times -1. Now, multiplication is commutative, even if we're dealing with it up here. The thing is that I would actually probably do it in this order right here. First of all, you don't want to do the 5th power. You don't want to raise 16 to the 5th power. I promise, okay? You want to make it small first. And of course, when you're dealing with fractions, it's always just a little bit more taxing on your brain. Not that fractions are hugely taxing, but anytime you have a numerator and a denominator to keep track of, you're more likely to fall into careless errors. So I would flip it over last, okay? But what you need to do here is basically rewrite this as 16 to the 1/2 to the 5th to the -1. Now you don't have to write it like that, but basically you need to do all three things. Now taking the square root, you want to make it small first, so that's going to be 4 to the 5th to the -1. Now remember that 4 is 2 squared, so you could think of this as 2 squared to the 5th to the -1. That makes 2 to the 10th, okay? Well, 2 to the 10th, okay, should be really easy for you, okay? And because all you got to do is just like take out your digits, right? And 2, 4, 8, 16, 32, 64, 128, 256, 512, 256, 512, yeah, okay, and then 1024. Okay, so that winds up being 1024 to the -1, or 1 over 1024, and that is the ultimate answer. Okay, that is basically this without the exponents involved. Now, and not all of them will be that nasty, and not all of them will have big numbers like that, like 1024, but what you need to do is you just need to basically figure out the things, the 1, 2, or 3 things that the exponent is asking you to do, put them in the most advantageous or strategic order, and then basically do them one by one, okay? And the thing is that if you can go from here straight to here in your head, bonus. If you're one of those people that's going to get it all garbled in your head and you actually need to see it written out, great. That's really not up to me. But what I do need you to do is I do need you to recognize what is going on here, and I do need you to have at least be asking yourself the question of what is the most strategic way to go about doing it, okay? But some of them will be, easier. It'll be like, 8 to the 2/3. And of course that winds up being 8 to the 1/3 squared, which is, 2 squared, or 4, right? Because we want to take that, you could, it's fine. 8 is small enough to where if you wanted to take it instead to 8 squared and then to the 1/3, you get 64 to the 1/3, which is also 4. but it's just usually a good practice to default to doing the root first. Okay. Alrighty, let's go ahead and move on to some that have some variables in it. Okay, so let's say we are asked to simplify 3x to the 2/3 times 4x to the 3/4. Now, remember, multiplication is commutative, so I can reorder that to 3 times 4 times x to the 2/3 times x to the 3/4. And then, of course, we can deal with the numerical factors together, and we can deal with the variable factors together. Now, remember that this right here is going to be an application of a to the m times a to the n is equal to a to the m plus n. The problem is, and it's not a huge problem, the problem is that in order to add those, you have to get a common denominator. Now 3 and 4 are relatively prime, and therefore their least common multiple, or their lowest common denominator, is 12. Over here you have 3 times 4, so this winds up being 12. This needs to be this needs to be multiplied by 4 over 4. So basically you need to unreduce 2/3 into 8/12, and you need to unreduce 3/4 into 9/12, or you wind up getting 12 times x to the 17 over 12. Okay. And remember that when we're talking about, when I keep making recourse to changing the form by unsimplifying something, getting a common denominator and sort of unreducing these fractions is sort of the paradigm, is the paradigmatic instruction that you've already received of how to do this, right? You know how to reduce fractions to go from 8/12 to 2/3 and to go from 9/12 to 3/4, but you've been taught strategically to actually unreduce them so that they match in their denominator, and you can actually do the sum or the difference that you're being asked to execute. We'll talk about that again and again and again and again and again. Let's go ahead and move on to the next one. Let's see. Let's do 72 x to the 3/4, and this is going to wind up being pretty close to the same thing, but just in terms of a quotient, and therefore a difference between those exponents. Now this winds up being 72 over 9, because here's the thing. We rarely remember that we're used to smushing things together in order to simplify, but we rarely think about pulling things apart into their constituent factors, especially to do so strategically. And if all of this, if the numbers right next to the variables kind of it sort of clouds your vision and gets really messy and you just can't concentrate, separate them out, okay? 72 over 9 can be pulled out as a separate factor from x to the 3/4 over x to the 1/3. And of course we already know what we're going to unreduce these to. X to the 3/4 becomes x to the 9/12, and x to the 1/3 becomes x to the 4/12. Now, in this particular one, it's going to be the analogous a to the m over a to the n is equal to a to the m minus n, which is why we also had to get a common denominator. But 72 over 9 reduces to 8, and x to the 9/12, sorry, it's not supposed to be an equal sign, x to the 9/12 minus 4/12, or 8x to the 5/12. Okay, and that is it simplified. We'll go ahead and do one more example, and then we'll move on to properties of logarithms. I'm not going to make 18,000 videos on this, especially considering the fact that this should be not only review, but really, really review-ish. Let's go ahead and do, 2y to the 1/5 to the 4th, all of that over y to the 3/10. That's supposed to be a 3, by the way. 3/10, okay? Well, the first thing that we need to do is we need to actually execute this for, so that basically the y to the 1/5, which of course needs to be canceled, not canceled, but needs to be simplified with this y to the 3/10. It needs to be freed up from those parentheses, and the only way to free it up is to apply the one that says that a product raised to a power, you have to apply that power or that exponent to every factor. Now, where you're going to go wrong, the place that I see most of the mistakes on this is, of course, you'll be so intent upon getting the exponent right for the variable that you'll forget that it also needs to be applied to the numerical factor. It's 2 to the 4th y to the 1/5 to the 4th over y to the 3/10. Now, you probably don't need to see that step, all of you, but I'm just putting it in there just to illustrate a point. Now, 2 to the 4th is 16. Y to the 1/5 to the 4th is y to the 4/5. But let's go ahead and call it 8/10, because I know that I'm now going to want to deal with this ratio right here and to simplify it by rules of exponents. And that winds up being 6y to the 5/10 or 1/2. Okay. In the next video, I'll go ahead and I'll set up the properties of logarithms, and I'll show you sort of how they parallel the rules of exponents, which shouldn't surprise you. And then we'll do some more examples off of the same worksheet that I compiled for you. As always, if you have any questions, please do shoot me an email. Bye.